Hello everyone, this is Mo and it's our third session in our user-centric design course journey, and today we're going to cover a very interesting and close to my heart topic as well. It's about object psychopathology, and again I'm really sorry about the very complex word, but this is the real terminology and how it goes. But I promise you something, by the end of the session you will be very familiar with this term and you're going to understand it inside out. And more importantly than theory, we're going to apply it as well in a lot of very real examples and practical examples. This is not a textbook training. This is not a theoretical training. Most of these things I've used myself in a lot of the projects we worked in SAM product design, or in my personal designs as well in my career. So again, let's get started. Today is about user object psychopathology. So the first thing you need to understand in the user object psychopathology is what we're trying to do, or what we're trying to establish, is the psychopathology between how users do things or achieve things. And there is no better reference or better theory developed than the one developed by Don Norman in the Design of Everyday Things. And this book is amazing. If you're a designer and you've done any design course in your I would say academic career, you will understand exactly what I mean. And if not, please pick that book up. It's very good. This is not a commercial or anything. Just this is really a genuine call for guys. This is a very good scientific reference, very good book and study about design and interaction or user interaction. So I really highly advise if you could pick it up and read it. In this particular section, I'm going to cover a lot of points from that book. Actually, I borrowed one of these charts from that book, particularly about the goal and how we have two gulfs of execution, the gulf of execution and the gulf of evaluation, or we have two gulfs of execution and the gulf of evaluation. And these two gulfs are usually referred to in that book as the seven, in the seven stages of action. So these two gulfs is basically how the user perceive any object in the world from the execution standpoint and from the evaluation standpoint. And again, this is very dry, so I'm going to try to put some more words behind it to make it more understandable. So first of all, like any user in the world, like when they're trying to do something, there is always the goal forming. So basically in their minds, there is a goal formed that I want to achieve something. This is step one. Step two, the plan. What course of action they're gonna take or what we're gonna do. So there is a planning phase, even if it's very short, even if it's very kind of in duration. It doesn't seem as much, but it exists. There is that stage where you plan what you're gonna do. Then you're gonna specify the action sequence. Then you're gonna perform those actions. Then you're gonna perceive those actions, or perceive what happened because of these actions. Then you're going to interpret these perceptions, and then you're going to compare them between what you had in mind as the goal, and then you compare the outcome with what you are getting. So Don Norman in the book called these the seven stages of action, because it starts with a goal forming and it ends with a comparison of what the goal was. So let's take a specific example, again called out in the same book, and I'm gonna just briefly go through it, but it's very easy to comprehend once you put it in words. So basically, he's saying, or like the book is basically going as, imagine a user reading a book. So as somebody is using your product, i.e. the book in this case, and or you're designing a smart home, for example, like that's another good application for such an example. But let's focus on the 7 stages of action in the time being. So basically he's saying, if your goal is to read a book, but basically what you're doing, you're reading a book and something interrupts this action. basically sunlight is going down, sun is setting, and this is a world trigger, which is something we're going to use we typically use in the product design world, because there is a lot of triggers. There is like human triggers or other people triggers, and there is like world triggers, stuff that you cannot control per se, and or environmental triggers, and we're going to talk about that maybe in one of our next videos. But the point here is you're reading your book while the sun is setting down, and all of a sudden, okay, your goal of reading the book is compromised, right? So you need to do something to counter that action, which is basically your brain starts the planning process, which is how can I increase the light in the room, right? So open curtains seems like a good like course of action, but eventually you're gonna need to do something else. Another plan comes to mind, which is like let's turn the lights on. So you plan different scenarios, then you're gonna specify, okay, I want to do that, which is turning on the lights. Then you're gonna specify the actual steps that you're gonna do. Okay, so in order to like turn on the lights, how can I do that? Shall I put the book down, go click on the switch, then go back to my chair or couch or whatever? Or shall I pick up my phone? If I have a smart device at home, then I turn the light on or whatever. Then based on that sequence that you specified, you actually take the action. Then you see, okay, is that light enough to read the book? That's the perception part. Then you actually comprehend that. So this is the perception, and interpretation is very tricky, but this is very tough to describe. But the perception is you actually perceiving the light or whatever happened as the actual action on the world. The interpretation is putting that in the context of reading. So perception is the light being increased. Okay, I flip the switch. Okay, I got more light. Interpretation is interpreting that in the context of reading, i.e., is that better? Is that amount of light good enough for reading or not? Then you're gonna compare, okay, is that what I desired from the beginning? Yes, it is, or no, it's not. Then less light, more light, or then there's another goal forming, and so on and so forth. This is a very good example, again, laid by Don Norman in the book. But the idea for me is, where should the designer focus? The designer is very much like the product that you're designing. If you're designing an object for a human or a user to interact with, you are basically helping them or assisting them to achieve steps 4, 5, and 6. Step 7, 1, 2, and 3, they're basically happening in their brains, in their minds. You cannot do anything about them. You cannot actually invade that space and help the user with. Maybe in the future, if they develop, or when we develop something in the input and output, and like where you could latch things to your head. But again, until that moment comes, we're basically focusing on the physical objects, where like you help them perform the action, perceive the state of the world, interpret that in an essence. Okay, so this is the designer focus. You help them in 4, 5, and 6. Okay, so in the 7 stages of action, what you basically did is you help the user tend to their subconscious goals. Again, these goals are always happening on the subconscious level. Usually most goals are nested. So you want to read the book. Why? Because that's the goal. Like on its own, it's a goal. Why? Because I'm studying for an exam. Why? Because I want to go to college. Why? Because I want to get a good job. Why? And so on and so forth. Usually, like every goal is a part of a bigger goal, then a bigger goal, then a bigger goal. Then the biggest goal should be something more visionary and more strategic as your life purpose and in kind of upbringing and background and culture shaped you during life. And again, like I do not want to get too philosophical here, but you got the point. So what you're trying to basically do is to assist the user during those subconscious moments and conscious moments. And the subconscious moment, and again, what we're talking usually about when we're talking about the subconscious in the user mind, we're talking about something that is dubbed system one. System one in your brain, this is the fast, automatic, very quick type of like not thinking brain. And the conscious brain, which is the more slow, controlled, and mindful of, this is the actual thinking. When you say, let me think about it, this is system two. When you don't think about it and you just do, this is mostly subconscious, system one. When you're actually investing mental facilities into something, this is system two. So what I'm trying to say with this is, you as a designer need to get to that visceral, behavioral, and reflective, which is the three stages of perception. Visceral is system one. Behavioral as well is system one. Reflective is system two. And let's elaborate a little bit with some examples. It will be super clear in a second, I promise. So visceral, system one. Visceral is, again, as said, this is your system one. This is your non-thinking brain. This is the part of you that does not think about something. When I'm moving my hands like this is system one. I cannot control it. It's part of my gestures, my programming, my years and years of talking with people, perceiving their body languages and so on. It's built inside me. I cannot help it. Right? So if any of you told me like, please stop with the hand gestures, I cannot, I promise. I tried more than once. So again, it's subconscious, and it's most importantly, it's fast, right? And this is how you survive. This is the lizard, like they call it the common brain, the lizard brain, whatever you want to call it, because they're saying this is lizard brain because this is the first thing that develops in you as you're a baby, or like is part of our evolutionary as, I don't know, lizards and stuff. So protective mechanism, when we are started by something, what usually kicks in, if somebody like, I don't know, throws a book at you, what you do this, when you dodge it, this is your protective system. This is system one in the game. This is visceral. When a cat or a dog dodges something, when they move around and somebody startles them, this is your protective system. Again, the system one, or the visceral system, is more about perceiving, and they're very fast to judge. It's either good or bad, safe or unsafe. And it's fast, but it's very limited in what it could learn, and it's highly emotional. So if you think about it, how as a designer you do this, you make it part of your mission is to keep that system happy. How to keep that system happy? By making things organized, by making some things less confusing, more, as you can see, for example, from the Apple example, like everything seems so clean, so elegant, so minimal. This minimalistic approach is helping your visceral brain feel calm, feel relaxed, feel okay. Nobody's trying to stiff me. Nobody's trying to take something from me. Actually, everybody's inviting me in. Everybody's inviting me to take a look at the phone, pick it up, play with it. All of this is very inviting. This is talking to your visceral system. So whenever you be in a place, or you are in a place, and you feel comfortable that way, this is your visceral system, not on edge, very relaxed, very happy. And again, this is a lot of design work and effort to make it that way. Same things in the supermarket when they're organizing the aisles and how things are organized in the sequence and all of that. That's a lot of science, trust me. There is a certain color pattern. There is a certain aisle route, however you want to pronounce it, that you take throughout the grocery store, and everything is very accurately and well thought of to make you look and have that experience in such a way. So again, visceral is something that you always need to take care of, or you need to think about when you are designing things for users. Okay. The second is the behavioral system. And again, this is still system one. This is still subconscious majorly, but you could influence it. You could teach it stuff. So when I'm telling you, hey, what is do you know how to play the piano? I was like, no, I cannot, I do not. Okay, so what if I told you, can you learn to play the piano, or how can you like learn a new language? Yes, it is possible, but in order for you to really play the piano or like speak a new language, you need to learn. You need to learn, you need to acquire knowledge, and then you act upon it. If you want to, for example, one of the main things you need to master as a designer is sketching, or not neat sketching per se, but the fact or the idea of putting your thoughts and concepts on a piece of paper. This is very important because it helps you visualize things. And again, maybe we could do a separate video on that. But the idea is, in order to learn how to sketch, you need to sketch a lot. In order to learn a musical instrument, you need to play that instrument. So it's behavioral. Anything that is behavioral, like brushing your teeth, like I don't know, like establishing a good habit of running in the morning, for example. All of this is easily, or not easily, this is programmable through some effort at the beginning, then it becomes a habit, it becomes a behavior, right? So how you do that, this is, you're trying to move things from conscious, like intentional, to subconscious and sub-intentional. And in this, like, how can this be helping you as a designer? Like, again, how you could react to that behavioral system in you, or like in the user's brain in this case. You need to think, what do you want the user to learn, i.e. invest time and effort at the beginning in order to master that, and what, no, you do not want the user to do that effort. And again, here the decision is it's very interesting, because if the user is going to use your product daily, I don't know for how many hours, minutes per day, then a behavioral change is okay. Like if you're switching from a joystick, for example, I play with a PlayStation joystick and I want to move to an Xbox joystick. It will take me some time to get used to that. Getting used to, that's behavioral. Once I get used to that, I'm already, like, my brain now is programmed to use the new joystick. So if I'm investing that much effort, this means I have to, I don't know, own a new console. But you should not expect from a user, I don't know, like for their entire life used to having a certain, I don't know, number pattern, to switch that number pattern for that particular terminal that you're designing for an airport, that they are just going to visit for a few minutes every, maybe once in a lifetime, and maybe a couple of times in a lifetime. So you should stick with the known pattern of 1, 2, 3, 4, 5, 6, 7, 8, the one that everybody knows, not, I don't know, having the 1, 2, 3 vertically, for example. So again, behavioral is more about what should the user learn in order to use your product, and what should the user have learned in the past in order to use your product. And if it's neither this or that, like which other system should they be working with? Usually when users have trouble working with something is because they have been programmed by another product, previous products, to do things in a certain way, and now you introduce a new product, but without providing the visual cues, the sound cues, whatever manual, whatever training manual, to educate them about what new should they do in order for them to use your product. Like for example, like when we switch from the this USB-B, a micro B, I guess, to the USB-C, and this USB-C did not need a lot of convincing, right? Because it doesn't need you, it doesn't require you to learn anything new. You already learned the hard way on the USB-B that you need to orientate your plug in a certain way in order for it to fit. But now and the same thing for the USB, like the USB port, like that one, it has a certain orientation. But now with USB-C, you do not need a certain orientation. All what you need to do is just plug it. So that is super cool, and it's a good design improvement because it actually takes back one thing that you had to care about, like the orientation, and it gave you a non-orientation specific cable. Then there is system 2, which is the more reflective. This is the deliberate decision making. Usually this is, and if you're having a product that has a high interaction with the user, like a computer. When you're using a computer, you're thinking with the computer. You're deliberately taking decisions and assessing and evaluating with your system 2, with your active, slow, again, slow here is not an insult or anything, but your system 2, which is your thinking brain, your reflective brain, is slower than the behavioral and the visceral by design. But they are more sophisticated and they could take more calculated decisions and highly analytical for that matter. And in this case, what you just need to do is to make sure that the evaluate, assess, and take decision part is very clear in your product. So now that we talked about the 7 stages of action, and we talked about the psychopathology of your brain, system 1 and system 2, and the 3 levels of processing, which is visceral, behavioral, and reflective. How can I apply this? This is a lot of good theoretical talk, but in order to apply it, you just need to do these 6 things in your products. So these are the actionable pieces, and to be honest, I have some designers that always forget about these things, but they do not forget about these 6. So these 6 hexagons are super important, and these are the kind of distillation of today's session. If you really want to come out of something out of this session, these are the 6 things you need to think about. Any product that you're designing needs to follow or has to follow these 6 principles. You need to check these 6 boxes when you're designing them. First thing is affordances. And affordances, as called by Don Norman, is the term affordance refers to the relationship between a physical object and a person. For that matter, any interacting agent. So in other words, it's the properties and the user abilities. So the chair and the human is basically, the human is the user and the chair is the object. So if the chair affords lifting or sitting on by all users, right? Because every user can sit more or less, right? Unless there is like a certain reason, medical reason why not to. But the lifting of the chair is ability dependent. So depending on the user, you need to think, is this chair light enough for that user, that particular user, to lift it or not? So if I'm designing a chair, I need to think what would be like my affordance. Let's check that box. If I'm designing this, I'm going to ask my designers, hey, did you think about the affordances for that chair? They're going to say, yes, that's a chair. Usually a user will need to lift it if it's a dining room chair, to lift it out and in, and maybe space them out if they need to clean under the dining room table or something. So it has to afford lifting. It has to be light enough for the user to lift. If it's a sofa, or let's say, I don't know what to call it in English, if it's a bigger chair that you use in your living room, this one does not need to afford carrying. It just needs to afford being comfortable, right? And being comfortable, as we said, this is for all users the same, or at least for all users of the same size the same. And maybe this is a good insight. If I'm thinking about that, one of the affordances would be the anthropometrics of the user, how big the user is, how big or small, like thin or fat, tall or short, etc. But this will come in the next section when we're talking about the anthropometrics and ergonomics. So the second thing is signifiers. So Don Norman again perfectly explained it. He said, affordances determine what actions are possible. So if the chair has a handle, like if the chair is light, I could lift it. But having a handle on the chair, I don't know, like in the back where like it clearly indicates where I could put my hand, that's a signifier. And a very good signifier I always see in the like in the bathrooms, for example, is this nice feet engraved on this on this push to open sink. Like it's very cool. It's very indicative. But in order for you to know that I need to push here for me to open it, they put this feet shape, right? This icon. This icon acts this as the signifier. So the affordances is the ability of things to be performed on something or on an object. The signifier is basically telling you where to apply it, how to apply it in this direction, in that direction. So if you ever saw one of these fire emergency doors, uh, this is very clear. Like they're writing push, and one of the good things about these doors, they afford pushing. And if you cannot read, like by momentum, what you're gonna do is you're gonna push this bar, and automatically the door is gonna open. So again, affordances is you designing the chair to be light enough for a user to carry it. The signifier, if needed, because not always the signifier is needed, you put a label, you put an icon, you put a directional arrow to where to apply the force in order for the action to happen. The next thing is constraints. So constraints here is a very good point. If you wish to minimize the chance of any wrong actions or any wrongdoing, you need to provide some constraints. So very commonly done in engineering, in the engineering world, that, okay, I want to have here like some M6 bolts, here M3 bolts, here M2 bolts, and so on, because this is better. Like why use an M6 bolt where I can use an M2 bolt, and the other way around, right? But due to that particular reason of constraints, if I'm providing you with, I don't know, an IKEA kit, it's better off to provide all of the bolts in the same size, if it's going to be cost-wise making sense as well, to minimize the chances of you using the wrong bolt in the wrong mounting location. And this is not lazy engineering. This is actually good design, because in if you think about it, you're gonna get one kit, and if you have to think every single time which bolt to use, this is an additional effort I'm throwing on you, I'm putting on you as a designer. Or if I'm gonna do that, I'm gonna make them completely size different, i.e. I'm gonna use M2 bolts in one location and M6 bolts in another location. So the difference is so big that it's super visible. You cannot mistake that bolt for that bolt. So here again, it's the constraint that you offer as a designer to your user in order to perform the correct action on the right location and not anywhere else. So think about this nice game that you play for, like that's designed for children, that they're trying to teach them, okay, where to put which block and so on. As a designer, you need to be careful that like one of these memes or one of these famous videos pranks about a kid fitting them in all locations. This is bad design, because if you can fit them in all locations, then the game, like, or the toy is already ruined and you didn't teach the kid anything. So this is one of the things, of course, you need to take care of, but this is basically a very good example of constraints. Another constraint is that you need to, like, another aspect of the constraint is you need to think about or need to take in consideration is some constraints are cultural dependent. So for one culture, for example, nodding in a certain way is yes, maybe in another culture is no, but that's not a constraint, that's just an example. But for some countries, a certain light, police cars, for example, have certain lights. So in another country, maybe they have different lights. So if you're going to use I don't know, like blue and red in the country in Europe, you're not gonna use the same colors in Egypt or in US or in China, and so on and so forth. So just keep in mind that some constraints are not particularly like international or universal. So if you are thinking about, I don't know, a certain um, constraint in a car in Britain, for example, or UK, then you need to consider that, okay, in that particular, the driver seat is on the right, not on the left, like in other European countries or in most of the other countries. So something like this, if I'm designing something with a certain constraint for a car, let's say a mount for my mobile phone, I need to think that, okay, that constraint, if I'm thinking about the sticker, I don't know, put next to the driver on the right, I need to reverse that sticker one more time if I'm putting it to the UK driver, and so on. Mapping. Mapping is a very good, again, I'm going to go with the Don Norman quote here. Mapping is a technical term borrowed from mathematics, meaning the relationship between elements and the sets of things. So here, this is a very easy one to understand. When you enter a certain a new building or a new apartment or whatever, and you start playing or flicking flipping the switches to get to the right light that you want to open or to want to turn on. Sorry. If you had that struggle before, what you suffered from basically is a mapping issue, i.e. you didn't know which switch open or turns on which light. Same thing for the oven. If you have an old oven and you have like these small diagrams like kind of a little bit worn out and you cannot see them, automatically what you're gonna do is you're gonna okay, which one of these knobs turn on which heater, and in this case it's going to be an issue until you actually figure it out. You're going to try them all until you map yourself this spatial correspondence, or like, okay, this knob turns out that heater, this light turns out that light, and so on. So what you need to try to do as a designer, you need to provide that mapping either in an intuitive way, if it's possible. So if I could put the knobs next to each one, which is not possible, of course, in the case of the heater, because in this case, you're going to overreach and basically burn the user's hand, and that's not something that you want to do at all. But if there is a possibility where you could map the knobs where it's unequivocally clear that this knob is controlling that particular heater, then in this case, then you're good. If you cannot do it that way, then you could put on a diagram. And one of the good things I learned is if you have to put diagrams, this might mean that you didn't invest a lot of time and effort in this natural mapping that you could, okay, if I would put it that way, it would be super clear. I do not need a diagram. But of course, sometimes diagrams and labels or icons are unavoidable. So in this case, it's okay as well. So it's not that you've done a great disaster if you added one of those icons, but it's usually a good reminder that, okay, can you check one more time? Can you do a better job in the mapping or not? One of the good old issues with those phones, I guess, like for the people like me that grew up in the 90s, were like they had a lot of functions, but these functions were like nested. So in order to do something, if you need to put somebody on hold or something, you need to click a button, then another button, or so on. So these nested menus were not providing a good mapping, as you could understand. In Sand, we had a lot of good products where we were thinking about mapping and so on. And some of those ideas involved a vending machine that I'm going to show you as maybe as one of the case studies in the future. That, okay, I had a very clear vending machine with very clear outlets. So how can I map those outlets with clear buttons? Luckily, in this case, I had an app to control the vending machine. So the mapping was super simple. I basically put the picture of the vending machine on the app, and that was it. Voila, done. So I didn't need to do anything else as like put the button or so. And to be honest, like the app integrated products are always a delight to work with, or a delight to design, because you could control a lot through a flexible screen, and you could iterate a lot without spending a lot of money. Feedback is, again, a communication, or like a communication signal that you need to consider when you are designing a product. So if you're designing, again, the normal definition is feedback, communicating the results of an action, is a well-known concept from science of control and information theory. So again, it's like feedback is a signal confirming an action was done. So if you are like clicking on an elevator button, that's a visual indication. So, but if there's a blind person, in this case, they need more than just this light ring around the number. Otherwise, they're not going to know whether they clicked the signal of clicking of that button has been received or not. The second is must be immediate and informative. So if I click on a button and like 3 seconds later it beeps, it's not giving you too much, right? Because you will think, oh, okay, it didn't work. Then you're going to click again, then click again, then click again. And some of these applications, if you click twice, you cancel. If you click 3 times, you get the order. So if you get an even number of clicks, you're canceling basically your action. And this is not very cool, right? So the feedback could be a visual feedback, or an audio feedback, or a touch feedback, like in the case of these small bumps that you have as like braille, bumps on the keypad in order for you to know which key is which. So for example, the number 5 is always marked, so you know that 1, 2, 3 is on the top for these credit card or ATM card machines. So you need to think about a couple of things. One is, like, again, what type of feedback am I integrating? Again, for this particular vending machine, one of the feedback we've designed in was this color feedback. So, light feedback. So when a user uses the app and selects a certain compartment out of the vending machine, the entire machine goes black except for this particular vending machine compartment. So the user is very clear that, okay, now my order is received. Now I'm just waiting until the machine vends or gets pushes out the product to me, and that's it. Very known way of communicating as well feedback is beeps or sound. So sound is very nice, but again, it's very intrusive. So be careful when to use it, because you do not want a keypad that beeps all the time, because it becomes annoying very, very fast. But as well, it's very useful if you're designing something with an alarm, like, all of these fire alarms or washing machine I'm done alarm, etc. So just be careful when to use feedback and what form of feedback you want to provide, whether it's visual or audible. And once you get this honed and you're determined on, okay, this is the specific way I'm going to go about, think about what, like, the mapping of it, and whether you want to add any constraints or signifiers to a specific part of your product. Last but not least is the conceptual model. And here the conceptual model is, again, is the way you understand any model in the world, right? It doesn't have to be right. It just has to be like your personal model. So the conceptual model and your mental model, or the user's mental model, need to match. If they're not matching enough, again, enough is keyword here, then the user will have trouble understanding and experiencing your product properly. So if I understand enough how to set my fridge temperature to a certain level, which is the example that Don Norman used in the book, this is a very good way to say, okay, I know that 3 means the highest. But later on, I think everybody had trouble to understand that growing up, like me included. Then later on, all of the fridge manufacturers decided to go with the universal Celsius. So again, if you put if you open your new fridge, you're going to see this is 1 degree, 2 degrees, 3 degrees Celsius, and that's it. Because this is more universal than trying to educate the behavior, again, behavioral programming of the user, and like trying to educate them about something they already learned in their life early on. So why put the effort and on them and on you to do that? So again, the point about conceptual models is you want to make sure that the model in your designer head is easily transferred to the user head. So whatever the user needs to use the product is there for them, either in the manual, either in how they're like how you're walking them through the journey of onboarding through the app or through the for app-based products. I mean, so if you'll always see in the new products that are like, for example, like electronic devices that you're hooking to your PC, there is always this onboarding step-by-step, very easy 3-button or 3 step. This is how you're going to install it. This is what's going to happen. And that's it. You are not trying to make them a designer of the product like you, because that's your job. You're just trying to make what they need to know very easily understood. So what they need to know is matching what is real, because the frustration happens like usually when what they have in mind and what they are having in what they're having in reality, they're completely different. So for example, again, back to the fridge example, if the guy puts it at 3, expecting 3 degrees, and he's getting or she's getting 8 degrees because 3 is the lowest, right? The lowest, I mean the lowest refrigeration power, right? So in this case, you're not giving them enough information to build a mental model. So our job as designers is to make sure that the mental model of the user, or that is conveyed to the user, is the same mental model that we have, because we're the experts and we're the designers and we know the product inside out, or just enough to make sure that they can use the product. And just enough here is key, because again, we do not want them to be designers of the product, because again, who has the time? And this is our jobs, not their jobs. So for the vending machine product, for example, all what I wanted the user to understand, if you click on that compartment, this is the compartment that's going to light up, and this is the compartment, this is going to be the product that you're going to get, and this is what you're going to get paid for. That's it. So click here, you get that, period. How the product works inside, how the programming works, how the servos push the product, and how the door opens, and all of these things, this is mine to figure out. I do not want to burden the user with that. But that much I need to convey to the user. So the conceptual model is matching the design, or their mental model is matching the conceptual model of the product. So that has been the end of our episode today. Again, these are the references I've used specifically today. Of course, we focus on the design of everyday things, and Thinking Fast and Slow the design of everyday things by Don Norman, and Thinking Fast and Slow by Daniel Kahneman, or Kahneman, if I'm pronouncing this right. And again, I used some of the examples from SEM Product Design. And again, I hope this was informative for you, as it was fun for me. And hopefully we will continue next episode very soon. Thank you very much, and have a good rest of the day. Bye.